In this presentation, we're going to look at binary number conversion. And what I mean by that is converting from binary to decimal and decimal to binary. I have two little tasks here. The first is express the decimal number 91 as a binary number, and the second is express the binary number 110110 as a decimal number. So I'm going to move on here. I have set up this table here. In the first column here, I have number. I'm going to explain what that is shortly. Division by 2, so whatever number we have here, we're going to divide it by 2. We're also going to set up the quotient and remainder. Now, by way of demonstration, I think I should get straight into it. First off, I'm going to divide 91 by 2. Now, the quotient is the integer part of this, so it is 45. And the remainder is going to be 1. So what happens when you divide 91 by 2? Your answer is going to be 45 remainder 1. That's a way of explaining your division without using decimals and fractions. What we're going to do is repeat this division, and that's why we call this the repeated division method. We're going to constantly divide numbers. The number we're going to bring down for the next phase is the quotient. So we're going to bring down 45 and going to use it as the number for the next phase. Again, what we're going to do is divide that by 2, 22.5. And again, the quotient is going to be 22, the integer part of this, 22. And the remainder is going to be 1. So we're going to bring down 22. Divide that by 2, we get 11. The quotient is 11. And the remainder is going to be 0. Now, here I'll draw your attention to the fact that both 91 and 45 are odd numbers, so that's why we get a remainder of 1 here. And 22 is an even number, so that's why we get a 0 here. So odd, get a 1, even, get a 0. And I'm going to move on now and hurry things up. We're going to bring 11 down. The division by 2, 5.5, that means a quotient of 5 and remainder of 1. Bring 5 down from the last phase. Division by 2, we get 2.5, that's quotient of 2 and remainder of 1. Bring down the 2, division by 2, we get 1, quotient 1, remainder 0. And lastly, we bring down the 1, division by 2 is 0.5, quotient is 0, and remainder is 1. Now, this is where we are finished. When we get a value of 0 here, there's nothing more to bring down to the next phase. That's when we know we have reached the last phase of the repeated division method. So what is our answer? The answer is these values in reverse. So the actual number we're looking for is 101, 1011. And it is these values in reverse order, or starting from the bottom and working up. So 1, 0, 1, 1, 0, 1, 1. Okay, so that's the first task done. And the correct answer is 101, 1011. So the second task is to express the binary number 110110 as a decimal number. So here's our bits. Now I'm going to have a number written up here. What I'm going to do is, working from right to left, I'm going to write down each of these digits separately, or bits actually separately, binary digits. So 0, 1, 1, 0, 1, 1, and again that's moving from right to left. Now, what we're going to do is apply powers of 2. So I actually wrote out the powers here separately. Just to be clear, we actually start with a 0 in the first instance, then 1, 2, 3, 4, and 5. So 2 to the power of 0 is 1, 2 to the power of 1 is 2, and so on. These are the weightings. And what we're going to do in this column here is we're going to multiply the bit by the weighting. So in the first case, I've simplified there. 0 times 1 gives us 0. 1 times 2 gives us 2. 1 times 4 gives us 4. 0 times 8 gives us 0. 1 times 16 gives us 16. And 1 times 32 gives us 32. So the answer is actually going to be the sum of all these products here. And the answer is 54. So express the binary number 110110 as a decimal number. The correct answer is 54.